We're going to look at several different examples in this video, but what we're going to be doing in this one is just look at how we are going to write a formula when we're given the full entire name. And then in the next video, you'll be given the formula, and you'll have to write the name. So there are a few rules, and if you follow these, you will have much better luck than if you just try to look at it and say, I don't know how to do this. So follow these rules every single time. The first thing you need to do is you're going to be given the name, so you are going to need to find the symbols for those names on the periodic table. And along with the symbols, you also need to write down the charges. The charges are incredibly important, and as we go through some examples, I will show you what we do with those charges. Then what you're going to do is you're going to take the charges and you're going to crisscross the charges, and I'll show you what that means in a second as well. But the number is going to drop down behind the opposite symbol. Okay? Again, as we practice them, it becomes a lot easier than me just telling you what to do. Now, there are times that you might need parentheses, and this is only sometimes. Okay? And this is only, okay, you have to have a polyatomic ion. If you don't have a polyatomic ion, then no parentheses. Okay, so it's only if you have a polyatomic ion, and only if you're putting a number goes behind it. Okay, so only if you're going to be putting a number behind it, like a 2, 3, 4, 5, whatever, no ones. So only if a number goes behind it. And I'll show you some examples, so again, please be patient. Promise we're going to get there. Just a reminder, because this goes, we've done this already, but there are no ones. So if it's supposed to be one of something, we don't actually put the number 1 down as a subscript, only 2 or higher. All right, let's actually do an example. Okay, so here is calcium phosphide. Now, if you see the word calcium, and we know that calcium is a Ca, and if you look at the chart, your periodic table, we know calcium is in group 2, so we know it has a +2 charge. And phosphide, remember the ending changed, so really this is phosphorus, and phosphorus gets the ending change for phosphide. And phosphorus, if you look on the periodic table, is a -3. Okay, so the first thing you should have written down is, from step number 1, you write down the ions, so that would be the symbols for your ions, and the charges. You have to write down the charges. Now the next step is to crisscross the charges. So that means that this 2 is going to get dropped down behind, and it gets written as a subscript, so they're not going to be high anymore. You're going to bring them down and put them as subscripts, low, down below the element. And the 3 that's on the phosphorus is going to get dropped down behind the calcium. So this is what it's going to look like when you're done writing it. Notice that the pluses and the minuses are gone. Those are not included in the final answer. It's just the numbers down below. Now here's why those charges are important. When you're doing an ionic compound, your overall formula has to have a charge of 0. Okay, 0, charge of nothing. That really doesn't look like a 0, say nothing, charge of 0. So right now, having a +2 and a -3, those have charges. Okay, this formula has to have a charge of nothing, 0. So your pluses have to equal your minus charges. Now, when you look at how many calciums you have 3 calciums. Okay, calcium is always a +2. So you have 3 of them. So that means you have a +2 and a +2 and a +2. Now, for phosphorus, you ended up with only 2 phosphorus, but every phosphorus is a -3. Now, if we look at our total plus charges, what is +2, +2, and +2? That gives us a +6. What is a -3 and a -3? Well, that's a -6. +6 and -6 give you 0. Okay, a charge of nothing. So by taking the charge on calcium and dropping that number down behind phosphorus, and taking the charge on phosphorus and dropping it down behind calcium, you are always going to get your charges to balance to 0 if you do it that way. Always. Okay. Okay, it has to equal 0 or your formula is incorrect. Let's do some more. So we have boron, oxide. So boron is the element B, and oxide is the element O. And we should know from where they are on the periodic table that we need to have a charge on these. So we need to look at the charges on our periodic table, and you should find that it's a +3 and a -2 on oxygen. So B +3 and O -2. Now again, you're trying to get these to balance out to a charge of 0. So how many borons do I need? How many oxygens do I need? You could try to figure that out, or you could just look at the charge, and again, if you drop that down behind the opposite element, it will 100% of the time work out where the charges will cancel to 0, and that's what we're trying to do. So in this case, we would have B2O3. Magnesium sulfide, okay, bringing in some new elements here. We know magnesium is Mg. It's the positive one, because remember the positive one's always written first, but we have to look at the periodic table, and it's in the second family, so it's a +2. Now sulfide, remember those IDE endings were things that they've just been changed. So that's really sulfur, and sulfur on your periodic table has a -2. Okay, so this is where we're starting with a +2 and a -2. Now I mentioned the crisscrossing, and that is absolutely going to work in every case, but I want you to notice that a +2 and a -2, if we just have one of each of those are automatically going to cancel each other out and equal a charge of 0. So we could put Mg2 and S2, and we could do the whole crisscrossing. But what's going to happen is that these are going to need to be reduced. Okay, so you want to reduce it down to the lowest terms, which makes it MgS as your final answer. Okay, final answer needs to be in lowest terms, which is just one of each. Now we're going to throw in something a little different. We talked about this in the last video. We mentioned what this means when you have the name of something with a Roman numeral behind it. Okay, first of all, let's get our symbol for mercury. So we know mercury is Hg. Now when you have a Roman numeral behind the element, that told us what the charge on the element was. And because it's the first one, it's always positive, but this is a Roman numeral 2, so that tells us that mercury has a +2 charge. Chlorine, okay, the IDE, and it's changed because it's written out as a name, but really this is chlorine, and that's Cl, and because of where Cl is on the periodic table, it's always a -1. So right now we're starting off with Hg +2 and a Cl -1, and we want to know how many Hg's do we need, how many chlorines do we need, so that this will equal 0. This will be neutral. Again, if you take the Roman, not the Roman numeral, excuse me, if you just take the charge and you crisscross them, remember ones are understood, we don't write ones, so it's just going to be HgCl2. This means that I have 1 Hg and I have 2 chlorines. So Hg is a +2, and I have 2 chlorines, so that's Cl and another Cl, and they're each a -1. So again, my +2, -1, and -2 give me -2. This equals 0, so this is good. We want it to equal 0. If we do another one similar to that, only now we have iron, and iron is Fe, and this is the Roman numeral 3, so it's going to have a +3 charge. Oxide is oxygen, and it has a -2 charge. So we're starting off with Fe +3 and O -2. We're going to take our charges and we're going to cross them, crisscross them, so that we're dropping the 3 behind the oxygen and the 2 gets dropped down behind the iron. So we have Fe2O3. And we're going to do a few more and bring in some polyatomic ions here in just a moment. Let's do one more where we have a metal with a Roman numeral. Chromium is Cr, and this is a Roman numeral 2, so that means we have a +2 charge. Oxygen, again, is O with a -2. So we are starting off with Cr +2 and O -2. So keep in mind that just having one of this one and one of this one already will give us 0 when the charges will cancel automatically. So we just need only one of each. Okay, again, you could do the crisscrossing and do CR2 and the O2, but you have to reduce it down. So you're still going to end up with CRO. All right, adding in some polyatomic ions. Now these you do not have to memorize. Okay, you're going to be given a chart of these on your test. Ammonium is something that is unique. Ammonium is NH4 with a +1 charge. So NH4 cannot be changed. We can't change the N, can't change the H, and we can't change the 4. It has to stay that way. Phosphate is another one that was on that list. It is PO4. And it has a -3 charge. We're trying to have the exact same thing happen. Okay, NH4 +1, PO4 -3. We're still trying to get our plus and our minus to equal 0. That is the whole goal of making an ionic formula. So again, your charges are going to have to drop down behind the opposite. That crisscrossing is still going to happen. But this is where we may need to have some parentheses. Remember, in the rules it said parentheses were only going to be if we had a polyatomic ion and if we had to put a number behind the polyatomic ion. So what you don't want to do is do NH4, drop your 3 down, and then put PO4 and put a 1. Because now you don't have NH4, you have NH43. And that means something totally different. And first of all, we don't write the ones, they're understood. So we don't need that one at all. So here is why we need the parentheses. We need the parentheses here so that we can keep NH4 as one item. And this 3 says that we have 3 groups of NH4. So that parenthesis means that you have 3 groups of NH4. So I'm going to write that up here. We have NH4 +1, NH4 +1, NH4 +1. So we have 3 groups right here. 3 groups, 1, 2, 3 of NH4. Now, how many PO4 groups do I have? I don't have any parentheses around it, so I just have one PO4 group. And it has a -3 charge. Now our charges should balance to 0, so +1, +1, +1 gives me a +3. PO4 has a -3, so this all equals 0 when you have 3 groups of NH4. I know that was a lot of side work, but I wanted to show you that mathematically this really does work out. Let's do some more. Now this one has a little kind of a combination here. So lead is still Pb, and that Roman numeral tells us the charge on the lead. Acetate is C2H3O2, and it has a -1 charge. So that's what we're starting with. We're starting with our plus ion and our minus ion. We have to have a plus with a minus. And then we want our charges to cancel. We want our whole entire formula to equal 0. So in order to do that, we would need to have 2 of this group. Okay, if we have 2 groups of this, then we're going to have a -1 and a -1. I'm just not writing the C2H3O2 every time because it just takes time. And then we still have a PB with a +2, so this will be a +2, the -2, and this will all cancel to 0. Again, in order to have 2 groups of this, you have to put it in parentheses because this is all one item and you can't change anything about it. We can't change any of the 2's or the 3's or any of the elements. All we can say is that we need 1 of them or 2 of them or 3 of them or however many it takes to get this charge of 0. Now let's look at another one. We have 2 left, one more after this one. We have sodium and hydroxide. Sodium is just the element Na, and it's a +1 charge. It's on your periodic table. But hydroxide is new. Hydroxide is a polyatomic ion. It is OH, and it is a minus 1. So right now we're just starting with a plus 1 with a minus 1. So just having one of each of those, the charge is already balanced to 0. So just saying NaOH is fine. Notice that there's no parentheses around the OH, and that is because we only needed one. And so if we only needed one of them, we already have one already. Okay? So we don't need the parentheses unless we need 2 of them or 3 of them, or something more than one. Last one, potassium chromate. Potassium is on your periodic table. It's the element K, not P. P is phosphorus, so K plus 1. And then chromate's a polyatomic ion. It's CrO4 with a minus 2 charge. So we have K plus 1 and CrO4 minus 2. So in order for this charge, for everything to balance to 0, okay, again, think about crisscrossing your numbers because that will always work. You're going to end up with K with a 2 behind it from the chromate's charge. And then we're only putting a 1 behind chromate, so we don't need to write ones, and we don't need parentheses since it is only one of them. So CrO4 is still one group. Okay, we only needed one of them, so we don't need parentheses. Only needed one, so no parentheses. So K2Cr4 would be where we would need to leave that one off. Okay. Make sure that you are asking questions because I know this section can be kind of confusing. It does take some practice, and we will practice in class. So just be open to, making some mistakes and learning from them. I promise you'll get better at them, but you do need to ask for help if you need it. Other than that, I will see you in class for us to practice these some more.